Okay, so we continue with another example of this kind of problem of finding a pattern for the nth derivative. So another exercise. To find um, um, formula for f differentiated n times of x, where f of x is x times e to the x. So for the solution, we compute f prime first time, and we see that we have to apply the product rule, right? So we take the derivative of the first function, x prime e to the x plus x times e to the x prime, which gives us, well, x prime is just 1. It's e to the x plus x times e to the x, because e to the x is the derivative of e to the x. So we have e to the x plus x e to the x. And this gives us, well, notice that we have a common factor here. This is e to the x times 1 plus x. So for the second derivative, we need to differentiate this thing here, which, well, we're going to use this formula instead of the last one. I mean, they're both the same thing, but it's going to be easier for us to find the pattern for a reason you'll see very quickly. So this is the same as x e to the x plus x e to the x prime. And remember, we can compute the derivative here by simply adding the derivatives of these two functions, e to the x and x e to the x prime. And this is why I wrote it this way instead of the last, instead of using the last expression we obtained. The last expression is good for finding the general formula, but for iterating this, the previous step, or the expression here in the previous step it's better for purpose of computing things, because the derivative of e to the x is just e to the x, and the derivative of this we already found to be actually the thing that we have in the last step, right? We computed ax times e to the x prime, so we just get e to the x times 1 plus x. We don't need to do it again. Now, the thing here is we have a common factor of e to the x, so we have e to the x times 1 plus this whole thing now, 1 plus x. And this is just equal to e to the x times 2 plus x. Okay, so in this very short video, I mean, what I want you to notice is here you took the derivative of f once, and you got a 1 here. You took the derivative of f twice, and you got to, you see, we're differentiating f twice, then you got a 2 here. So if you're guessing that the nth derivative of f is going to be equal to e to the x times n plus x, you'd be right. And you see, the reason why is because you will be able to break the derivative as the derivative of e to the x. I mean, for the step 3, so when we differentiate 3 times, e to the x plus plus e to the x times 1 plus x, which is a derivative you already computed, which will be what we have here at the bottom. But you have to add e to the x. So another e to the x becomes a 3, and that's what's gonna keep happening when we differentiate one more time. You're gonna add another e to the x. So that's where this number is coming from. You're increasing the number of e to the x's that appear when we differentiate this expression multiple times. So yeah, and to cover the other examples that you may see, for instance, like derivatives of sines and cosines, we first need, I mean, so finding a patterns that involve sine, the derivatives of sines and cosines, we first need to learn how to differentiate these functions, or need to cover what these derivatives are. Okay, so that's actually the content of the next video. Once we do that, we can come back to this kind of problems and compute some other, and find out some other patterns, some other formulas for the nth derivative of a function. But yeah, so that's the thing. So this week, for this week, the material is a little bit shorter. But well, that's good. I mean, last week was you had an exam, so yeah. But yeah, we'll see each other in the next video where we cover trigonometric functions, which is the section 3.6.